Welcome to our class today. Today we want to look at chemistry paper 1 revision. So be patient, follow step by step to the end in order to benefit from this video. Let's look at the paper. This series of Amuka chemistry paper 1. This is June 2025. Let's start from question 1. The figure below shows protons, neutrons, and electrons behave differently when they move at the same velocity in an electric field. So we have been given plate, we have the plate A, we have plate A, we have plate B. So we have the neutrons. You know, neutrons have no charge, they have no charge. Protons are positively charged and then electrons are negatively charged. So if the protons have been attracted towards this direction, then it means plate A is negative. Because protons are positively charged, this plate must be negative for it to attract the positive. These electrons are negatively charged. For them to be attracted to plate B, the plate B must be positive. Identify the charge of the plates A, mark the A and B. We have said that so charge of A is negative, charge of B is positive. Suggests a reason why the atomic mass and atomic number of the two isotopes of an element are not always equal. Why is the mass number, atomic mass and atomic number of the two isotopes not equal? Of course, we know the isotopes have the same atomic number but different mass number. What causes the difference? It is the number of neutrons in the element. It is the number of the neutrons. So due to the difference in the number of the neutrons, that is what makes the difference. So the neutrons is what makes the difference. Complete combustion of biofuels made from the sewage sludge produces the greenhouse gas carbon dioxide. Suggest one possible environmental concern associated with the combustion of these biofuels. I will take you direct to the answer to save time. So what does that have? So remember, carbon dioxide dissolves in rainwater and results into the acidic rain. What happens? What does the acidic rain do? Acidic rains, once it arrives at the environment, it corrodes the buildings, it corrodes the gates made of iron, so it destroys any metal that it finds. Therefore, carbon dioxide dissolves in rainwater, forming acidic rain which destroy buildings, which corrode buildings and other. Give the name of another greenhouse emitted. So the name of another, we have around 3 of them. So give the name of another greenhouse gas emitted during the combustion. We have nitrogen 1. We have the nitrogen 1 and the methane is one of the gases. I want to caution you from using this one. I wrote them here intentionally so that to use. The question asks us to give the name. When you're told to give the name, you should give the name. So do not use the chemical formula when you are asked to give the name. Where do you use the name? Either. That is where you are required to use either. If you have been asked to identify. So to identify, you can either use the name or the chemical formula, but when you are asked the name, give the name. So we have nitrogen 1 oxide and methane. A patient was given the drugs with a prescription as follows. Give the interpretation of the prescription. So what does that mean? So we know very well that means that the patient should take 3 tablets, 3 times a day. Morning, for example, if the patient takes it in the morning, another one will be in the afternoon, and another one in the evening. So that one makes this prescription. So 1 in the morning, 3 in the morning, 3 in the afternoon, 3 in the evening. So give the interpretation of the prescription. The prescription, you write the patient should take 3 tablets 3 times a day. For example, morning, afternoon, and evening. Or the patient should take 3 tablets after every 8 hours. Why do we say that the patient should take? Because a day has got 24 hours. So you divide by 3 drugs, so that is 8 hours. Then the patient should should take 3 drugs after 8 hours. Next question. The patient decided to take the recommended number of tablets at 8 a.m. Determine the time the patient should take the next set of tablets according to the prescription. Therefore, if the person has decided to take 8 a.m. and each set, that is 3, each set is supposed to take 8 hours. Where did I get 8 hours? A day has got 24 hours, divided by 3 drugs, so you get 8 hours. Therefore, you add 8, you get 16 hours. So this person should take that is 16 in 24 clock system minus 12, that is 4:00 p.m. Therefore, the next time, if the person takes the drugs at 8 a.m., the next time she or he will take the drugs will be 4 p.m. Describe how you could prepare a 2-molar solution of hydrochloric acid from a 20 centimeters cube of 12.4 molar hydrochloric of the hydrochloric acid in the lab. How would you do that? First, you need to get the volume. So here you use that formula of dilution. We know that M1 V1 will be equal to M2 V2. So you use this formula to calculate the volume. You will get that the volume 2 will be equal to 124. So we need to prepare 124 of 2 molar of HCl diluted. So you use the formula and calculate this, then volume 2 will be 124. So remember, we are starting with 20 of the concentrated nitric acid, sulfuric hydrochloric acid. Therefore, what you do, it is the total volume we want is 124, so you subtract 20. So you are going to add distilled water, 104 distilled water. But you are told to describe. So how will you put it? You say measure 20 centimeters cube of 12.4 molar hydrochloric acid and dilute it with distilled water to the final volume of 124. Another students will say measure 20 centimeters cube of 12.4 molar HCl hydrochloric acid, dilute it or add 104 centimeters cube of distilled water to make it 124, which is required. So that's how you describe that question. Write the electron configuration of aluminium ion. Aluminium ion, remember aluminium is 2, that is 8, 3, that is 13. Aluminium is atomic number 13. So when aluminium reacts, forms an ion, it loses 3 electrons. The outermost electrons are lost. So this one is an ion, meaning it has reacted and it has formed an ion. Therefore, the 3 will disappear and we will have 2,8. 2.8 is the electron configuration of the ion. When an aqueous aluminum chloride, this one is added to water, a solution forms which is strongly acidic. A solution forms which is strongly acidic. That is very correct. The solution formed is strongly acidic because aluminum chloride is not like these other chlorides. Aluminum reacts with chlorine to form aluminum chloride, right? So this one combines with another aluminum chloride to form aluminum chloride dimer. And this aluminum chloride dimer, when dissolved in water, it forms a very strong acid. So suggest the pH of the solution formed when the universal indicator paper is dipped. So the pH will be either pH 1, pH 2, or pH 3. Do not give the range. For example, somebody says pH 1 to pH 3. Don't do that. So that one will form pH 1, pH either 2 or 3, because this one is strongly acidic. If you write the range, you are going to be penalized, and we don't want you to be penalized. Identify the ion in the solution which is responsible for the acidity property. Remember, hydrogen ions are responsible for the acidity, and hydroxide ions are responsible for the alkalinity. Alkalinity, that is the base, is hydroxide ions. Hydrogen ions are responsible for acidity. Very good. On the figure below, sketch a graph to show the trend in atomic radius of a successful element in the periodic three or in periodic 3 of the periodic table. So what happens across the period? Remember, as the number of protons increases, the atomic radius decreases. If you know that, then you should know that this is what happens. So if this graph goes like this. So this is how the graph will look like. It is either you use this line or this curve. This one and this one are well represented, and it is good to use either. You use either of them. So remember, explain your answer. Increase in the atomic number increases the nucleus charge. It increases the nucleus charge, meaning the number of protons increases, which then pulls the energy levels closer to the nucleus. So once the nuclear charge is increased, then the outermost energy levels, the electrons there, are pulled closer to the nucleus because the nuclear charge has increased. So I want to explain again that as you move from left to the right across the period 3, then you should know that the number of protons in the nucleus increases. That is true because we come from 13, 14, 15, 16, 17 up to 18 across the period. So as you move across the period, the number of protons increases, and once the number of protons are increasing, then the nuclear charge increases. Once the nuclear charge increases, what does it do? The nuclear charge pulls in a vuruta, pulls the electrons closer. It pulls the electron closer to the nucleus, reducing the atomic radius. The concentration of dilute hydrochloric acid can be determined by titration using standard solution barium hydroxide. Hydrochloric acid is added to the burette using the funnel. That is true, that's how we do it. Statewide, it is a good practice to remove the funnel from the burette before the titration. So why do you need to remove the funnel after you have read your 0 mark, the meniscus you have read it? Why is it important that you should remove the funnel even before you put your solution into 0 mark? It is important to do so to ensure the accuracy of the volume you measure, the measurement of the volume to be accurate. That's one. Number 2 is to avoid the extra volume which may drip from the funnel once the meniscus is reached. Therefore, it is important to do that. It is to avoid the extra volume which may drip from the funnel once the meniscus is reached, or also to ensure accuracy of the volume measured. Therefore, you need to be careful. Before the first titration, the 25 ml pipette is rinsed with the small volume of the solution barium hydroxide. The pipette you need to rinse the pipette with the solution. Why is it important for you to do so? It is to ensure that the pipette is not contaminated by the liquid with which you previously washed it with. So you need to use the reagent you are using to avoid contamination. Nitrogen oxide decomposes at high temperature as shown. This equation, these 2 arrows shows equilibriumity. So this one shows that the system is at equilibrium. Yeah, these 2 arrows shows that the system is already equilibrium, and it means that the forward reaction is endothermic. This reaction to the forward is endothermic because of this positive here. So the question says, state how the composition of nitrogen oxide would be affected if the pressure is increased. So if you increase pressure, how does the decomposition of nitrogen oxide would be affected if the pressure? Remember, increase of pressure, when you increase pressure to a system which is at equilibrium, then equilibrium will shift to the side with fewer gas molecules. So fewer gas molecules, what is that? Now, if you are dealing with pressure, remember we have 3 factors which affect equilibrium. Number 1, temperature, pressure, and concentration. Those are the major factors that affect equilibrium, a system at equilibrium. Now we are talking about pressure. For pressure, you need to look at the what is there here. Let me remove this. Now, on the left side, we have 2. So here, the number of moles is 2. This one here has got 2 plus this one, there is 1 here, so 1. So meaning on the right side, the volume is 3. On the right side, it is 3. I hope you have seen where I got the 3 from. So 3, it is 2 plus 1. So this is what we call the number of, so this volume, it is the number of molecules. And this volume is the number, the number here is the number of molecules. So you can see that on the left side, molecules are fewer. On the right side, molecules are in the number 3 and 2. So when saying, when you increase pressure to a system at equilibrium, equilibrium will shift to the side where we have fewer gas molecules. So where do we have fewer gas molecules? Here on the left side. Left side has fewer, right side has. Therefore, equilibrium will shift to the left. So equilibrium will shift to the left. That is the first thing you need to understand. Therefore, if the equilibrium we receive to the rect, that's the composition of nitrogen. So it means more of the nitrogen 4 oxide is going to be formed. So therefore, the composition will increase. The composition will do what? Increase. So the composition will increase, and I have explained how. A 0.317 molecule sample placed like that or that. And then given that at the equilibrium, it contained 0.12 moles of oxygen. So here you rewrite the equation. Rewrite the equation, and then you balance the equation the way it is there from part A. Therefore, we have 2, we have 1. So you can see this is 2, 2. So if oxygen has a mole ratio of 1, and it is the number of moles is 0.12. So if the volume here is 2, then it is going to be twice. So the question was, given that this, what was the question? Determine the moles of nitrogen 4 oxide gas at equilibrium of nitrogen 4. So it will be 0.4 because the number of moles here is 2. So here you say if 1 for oxygen is equal to 0.12, 2 will be what? It will be 0.2 moles. The figure below, figure 4 shows the bonding between oxygen and fluorine in a molecular structure. Label the bond shown on the diagram. The bond, which bond is this? This bond here is covalent. You can see this bond here is covalent. The bond is a covalent bond. Determine the oxidation state of oxygen on the molecule. So the molecule here, remember fluorine will combine with oxygen to form oxygen fluoride, right? So to get the oxidation here of oxygen here, what do? You simply say, remember fluorine is -1, so it has. So we are going to get the oxidation number of oxygen there. So what you do is you say F for F2 is -1 times 2 because of this 2 plus X for oxygen will be, because this is a compound, iron 2 fluoride oxide is a compound, so it's going to be 0. Therefore, we have -2 plus X is equal to 0. It means that X for oxygen is going to be +2. So the oxidation number is +2 for oxygen in the compound. Determine the oxidation state of oxygen. I think I have done the one in a wrong. So this one is supposed to come in. So what I've done here is supposed to be done here. Say the oxidation is 2. Write the electron configuration of oxygen in the molecule. Because it has already gained, oxygen has gained 2 electrons to be stable. So that is the electron configuration. The table below shows enthalpy change data. You study the table and answer the questions that follow. So you can look at this one. We have calcium ions going to calcium in gaseous form to calcium in aqueous. Calcium chloride ions in gaseous form, chloride ions in gaseous, and this is the enthalpy change in kilojoules per mole. Calcium ions plus 2 chloride ions in gaseous form when they form. Now this one, when ionic compounds combine to form an ionic compound, that is lattice, and that one is exothermic. That is lattice, a reverse lattice actually. That one is reverse lattice. But when we go this way, from when an ionic compound decomposed to form its ions in gaseous form, that one is endothermic, and it will have the same energy, but it will be positive 2237 if we reverse the process. Now the question is to determine the enthalpy change that occurs when solid calcium chloride dissolves in water. Dissolving in water, that one we call enthalpy of solution. Enthalpy of solution. So that's what we are going to look at. I will use the diagram on my answer to save time. So I have drawn this. So we have calcium chloride. When calcium chloride is dissolved in water, it will form calcium ions in aqueous, right? Now, calcium itself, from solid state to gaseous state, this one is called lattice energy, and which is endothermic. So I have drawn the energy cycle here, as you can see it. So the enthalpy from calcium to ions, you go back to the table. Calcium to calcium ions, the end is negative. Calcium chloride, that is this plus this is going to be plus. So we have used the plus here because this is calcium chloride decomposing to calcium in gaseous form. But this one is giving us a negative, the reverse lattice. So that is the thing you needed to acknowledge here. Therefore, this one we are put it positive because we are doing the reverse. Then chloride ions in gaseous form to aqueous here. Chloride ions in gaseous form to aqueous. We have this enthalpy change, but here to balance the equation we have 2, so we are going to multiply times 2. So that's why we have multiplied here times 2. And then calcium ions in gaseous form to aqueous. Calcium aqueous, this direction here, we give it negative. Here, it's negative 1650. That one remains the same. Now you get the total here, and it will give you negative 2378. Now to get this one, enthalpy change, H is equal to this. We are following this direction. So that one is plus 2237 plus minus this. Remember, plus minus. So negative times supposed to be negative. That's why we have used negative here. And you will find the final, the enthalpy for solution or hydration, we can call it hydration, is negative 141 kilojoules. Negative 141 indicates that the overall reaction is exothermic. That is now the next question we'll ask. How would the temperature change when chloride ion dissolve in water? The temperature will increase. It will increase because the reaction is exothermic. How did you know the reaction is the overall enthalpy change is negative, indicating that the reaction is exothermic. Therefore, the temperature will rise. Write the equation for the reaction of phosphorus with excess oxygen. So phosphorus will react with oxygen to form phosphorus 5. Then you put 2 here, and then you put 4 there. This is 10, we will have 5. So that is the equation on how you can write phosphorus plus. Using litmus paper, describe the test you could carry out in a test tube to distinguish between sodium oxide and the oxide of the oxide formed in above. So the oxide formed above here is phosphorus 5 oxide. Phosphorus 5 oxide, when nonmetals react with oxygen, they form acidic oxides. So metals react with oxygen to form basic, that's alkaline oxides. So magnesium or sodium oxide is basic, and this oxide is acidic. So when we dissolve this one in water, we form an acidic solution, but this one will form an alkaline solution. So you need to master Form 1 work where we have chemical properties of when elements react with oxygen. So sodium oxide, hello? Yes. Ndio. Unataka essay? Ya fathers ama ya parliament ama gani? Fathers. Utanitext WhatsApp. Na hii namba tu. Niko na essay 59, so essay moja ni 10, naweza chukua 5, 10, 20, 30 kulingana. Nimesema essay moja ni 10 bo. So inapenda, unategemea unataka ngapi? Zote ziko 59. Na mimi nitakuwa nachukua moja kama mbili kwa wiki. Haita unaanza na 5, haita 5, 10 hivyo. Sawa. Excerpt ya Samaritan ni 200, 23 excerpts. Hapana, zote 23. Hapana, labda naweza kupea 5 ama 10. Essays unaanzia 5. Unachukua 5. Unaweza chukua 5, 10 hivyo. Yeah. Jioni? Haya. Usikiwe naendelea. All right. So a sodium oxide solution turns red litmus. So we're talking about what effect do these have on a litmus paper? Describe the characteristics to distinguish between. So now we are going to use the red litmus paper and the blue litmus paper. Sodium oxide being soluble in water, it will dissolve to form a basic solution, and the basic solution will change the red litmus paper, the red litmus paper to blue. Phosphorus 5 oxide will dissolve in water to form acidic solution, which will change blue litmus paper to red, while sodium oxide solution will change red litmus paper to blue. Phosphorus 5 oxide will change blue litmus paper to red. And so the question was describe. Remember now the problem is you need to describe. So how do you describe? This is how you describe for you to get the marks, because you need to describe. The way you answer the questions matters. The way you answer the question matters a lot. Now, you say add water to each oxide in a separate test tubes to form solutions. Add water into each oxide in separate test tubes to form solutions. Point number 2, dip blue and red litmus papers into each solution. Sodium oxide solution changes red litmus paper to blue, while phosphorus 5 oxide changes blue litmus paper to red. And you are done. I have equation for the two electrode that combine to make a dry cell is here. Identify the oxidizing agent in the cell. So you need to understand electrochemistry very good for you to answer this question. You start by understanding that a substance that gives electrons is the reducing agent. And if it is the reducing agent, it undergoes oxidation. And you need to understand that oxidation takes place at the anode. So equation 1, zinc gives out electrons. Zinc gives out electrons. So the substance which gives electrons is a reducing agent. Those are the things you need to understand. A substance which gives electrons in an electrochemical setup, it is the one that is called the reducing agent. Reducing agent, this one occurs at the anode. So this one is going to take place at the anode. And at the anode, oxidation takes place. Oxidation takes place. This is where oxidation occurs. Let's look at equation 2. Equation 2, manganese 4 oxide is receiving 2 electrons. As the substance which gains electrons is the oxidizing agent. It takes place at the cathode. So at the cathode, we have reduction. Remember that. So this manganese is receiving 2 electrons from zinc, therefore it is the oxidizing agent. The one that gains electrons is the oxidizing agent. The one that gains electrons undergoes reduction. Remember that. Therefore, identify the oxidizing agent. The oxidizing agent here is MnO2. You see here I have used the chemical formula. I have not written the word because they have said identify. So when you identify, you don't need to struggle writing the name. Which equation of the reaction taking place at the cathode? I have already finished. Equation 2 is taking place at the cathode. As the substance which gains electrons undergoes reduction, and reduction takes place at the cathode. In fact, if you have any problem in electrochemistry, do not hesitate to contact. I will teach you on personal level until you enjoy chemistry. If you have a problem in electrochemistry, I have the medicine for you. So do not hesitate to contact. Which equation of the reaction is taking place at the cathode? We have said that is equation 2. Equation 2 is the one taking place at the cathode. By filling in the spaces provided, describe how student could give the difference between aqueous solution of potassium nitrate and potassium sulfate. So what are the reagents that are going to be used? Here we are going to use red nitrate. We are going to use red nitrate. We are going to use either red nitrate or barium nitrate. We are going to use barium chloride either. We are going to use barium chloride. We are going to use barium nitrate. Why are we using barium at the red? Because red forms a white precipitate with sulfate. Barium forms a white precipitate with the sulfate. But potassium sulfate is a colorless solution. observation with potassium nitrate. So when this reagent is reacting with potassium nitrate, we are going to form potassium. There will be no white PPT. There will be no white PPT. What if when we are going to react the reagents with potassium sulfate? The sulfate here, this sulfate in potassium, the ions will combine with barium, will combine with lead to form lead sulfate and barium sulfate, which are a white precipitate. So here, a white PPT are going to be formed. White PPT are going to be formed. Explain why metals such as magnesium, aluminum are good conductors of electricity. Why are they good conductors of electricity? It is because they contain delocalized electrons. Delocalized electrons are responsible for conductivity of electrons. That's why metals with higher number of delocalized electrons are even more. For example, aluminum is very powerful in conducting electricity when you compare to magnesium. Why? Magnesium has got 2 delocalized electrons, while aluminum has got 3. Conductivity increases as the number of delocalized electrons increases. Explain why give 2 reasons why aluminum is preferred to magnesium for making cooking pans. This one is simple. Aluminum reacts with oxygen, forming the protective layer magnesium oxide. And magnesium oxide, once it is formed, it does not react with water or that. But unlike magnesium, aluminum reacts with oxygen to form the protective layer of aluminum oxide, and which protects the surface of the pans from reacting with oxygen. But magnesium oxide formed can react with water. Magnesium oxide can react with water to form other things. So aluminum is more malleable than magnesium. It's more malleable than magnesium. That's another reason. Figure shows the apparatus used to separate liquid K and M using fractional distillation. So whenever you see fractional distillation, remember, substances separated by fractional distillation, they have different but close boiling points. So explain why fractional distillation is preferred to simple distillation to separate liquid K and M. Liquid K and M have got close boiling points, hence double condensation. They have close boiling points. Suggest labels that would be added to the position T and U in the figure to show the direction of flow of water. U is water in, T is water out. Water in, T, water out, T water out, U water in. In extraction of metals, both carbon and carbon oxide are used as the reducing agent. Explain why sodium metal is not extracted using reduction method. Remember, sodium is very reactive. Sodium is highly reactive, so it cannot be reduced by carbon. Carbon cannot reduce sodium because sodium is very, very reactive. So sodium is highly reactive metal, so it cannot be reduced by carbon. Why is carbon oxide and not carbon being referred to as the chief reducing agent? Why is carbon the chief reducing agent and not carbon? We know carbon is a reducing agent, but why is carbon used more than carbon itself? It is because carbon-2 is in a gaseous form, therefore it reacts more readily. It reacts more readily with the metal oxides, removing oxygen from them, unlike carbon. Unlike carbon. Carbon dioxide diffuses and occupy a larger surface area on the oxidizing agent. So if you don't understand that, explain what I have explained. I have told you that carbon dioxide is in gaseous form, therefore reacts readily with the metal oxides to remove oxygen from them, to reduce them. That one can be even simpler to understand. Carbon-60 forms hydrocarbons with similar chemical properties to those of alkenes. One such hydrocarbon is that C60H18. Explain why C60H18 is referred to as a hydrocarbon. What is an hydrocarbon? So the ones that use to define an hydrocarbon. An hydrocarbon is a compound which contains carbon and hydrogen only. So that's an hydrocarbon. C60H18 is an alkene, though with multiple double covalent bonds. Identify one chemical that can be used to test for the presence of a double bonds between carbon atoms in the alkene molecules. You can use acidified potassium dichromate or acidified potassium permanganate. You can use our orange acidified potassium dichromate, orange acidified potassium dichromate, or acidified potassium manganate, which is purple. You can use either. So the two reagents are okay for you to use. You can use acidified potassium dichromate. This is called acidified potassium dichromate, or you can use acidified potassium manganate 7. State the observation made when the test is carried out. So what does the acidified potassium permanganate do if it is an alkene? The purple color will be colorless. The purple color changes to colorless. Therefore, it confirms that it is present. State the observation made when the test is carried out using the chemical identified. We have said that the alkenes changes the purple color of acidified potassium permanganate to colorless. Chlorine is added to some drinking water suppliers to decrease the risk of people suffering from diseases such as cholera. State why the amount of chlorine added must be controlled. Why should we add a reasonable amount of that? The reason is simple, that excess chlorine is harmful to human health. That one you need to know, that excess chlorine is harmful to human health. It can cause irritation. It can bring bad taste in water and even form toxic byproducts in water. So those are the things which you need to avoid to ensure that the amount used is okay. It is to ensure effective disinfection while minimizing harmful effects and the byproducts formed. I have explained. Give the chemical family name for the group in the periodic table. So chlorine belongs to halogens. It is an halogen, and that is nice. Using a solution of lead-2 nitrate, explain how the presence of chlorine ions in the drinking water can be confirmed. How can you confirm the presence of chloride ions and using lead nitrate? Very nice. Add lead nitrate to the sample of water, then add lead nitrate or white precipitate is going to be formed. If the white precipitate, when warming, it dissolves to be colorless, that one is going to confirm the presence of the chloride ions. Add lead nitrate to the water sample in a test tube a white PPT is formed which dissolves on warming. That confirms that the chloride inside is chlorine because lead chloride forms a white precipitate which dissolves when warming, when you warm. Study it and answer the question that follow. Give the name of the type of the reaction shown. Give reason for your answer. What type of reaction is this? What type of reaction is this? Is it exothermic or endothermic? You can clearly see the reaction is exothermic. Why did I say so? Because you can see the reactants are up there, the products are down. So meaning the products have less energy. If they have less energy, though that reaction is exothermic. If the products have less energy, then that means it is exothermic. Exothermic, the products here have lower energy than the reactants. That's correct. Identify the arrow that represented the activation energy. Activation energy is this M, arrow M here. This is the activation energy from here up to here. K represents the enthalpy change. Heat change is represented by K, and that is very correct. K from here up to here is what we call enthalpy change. In the extraction of sulfur by flash process, water at a temperature of 170 is pumped into. This one is called superheated water. What is the function of the superheated water? The function is to melt the sulfur. To melt the sulfur. Explain how the temperature of 170 degrees is achieved. How is it achieved? It is by increasing the pressure. We are told that that water is heated at a specific pressure. You need to master that value of pressure that is given. It is to melt the sulfur by increasing the pressure. You will achieve 170 degrees superheated water. A student reacted nitric 5 acid with a base to form a solution of magnesium nitrate. Write the chemical formula of the base. So the chemical formula could be magnesium oxide or magnesium hydroxide. So that one, when you add nitric acid, you form magnesium nitrate plus water. The students evaporated the water and obtained a solid magnesium nitrate. In the space provided below, draw a labeled setup diagram which could have been used to evaporate the solution. So that is from 1 testing, if you remember how to evaporate. So this is the solution. This is the evaporating dish. And this is the water bath. You write the water bath. Don't forget to say the wire goes. And this is the heat. You must remember to indicate everything. So your diagram must be it must have what we call workability. It must be working. Give the name of the products formed when magnesium nitrate is heated. Magnesium nitrate burns to form magnesium oxide, nitrogen oxide, and oxygen. Remember, the effect of heat on nitrates. The most reactive one they produce, like magnesium, like sodium nitrate, will decompose to form sodium nitride. with and oxygen. But the middle, remember to revise that in order to be on the safe side. States how the thermal stability of the nitrates of group 2 metals change down the group. The stability increases down the group. The stability increases. In terms of structural bonding, explain why silicon 4 oxide has a higher melting point than carbon 4 oxide. Yeah, that's okay. Remember, silicon 4 oxide forms giant atomic structures, in which there are strong covalent bonds, But what about carbon 4 oxide? Carbon 4 oxide is a gas, therefore it forms simple molecular structures. Inside the simple molecular structures, there is what we call weak van der Waals forces. The weak van der Waals forces in the structures of carbon 4 oxide makes it to require very small amount of heat. Therefore, they will require small amount of heat. So carbon 4 oxide has a simple molecular structure with weak van der Waals forces, which require small amount of heat to decompose. Complete the following nuclear equation to show the mass, number, and atomic like that. You need to complete. Now, we have three emissions that are given. We have beta, gamma, and we have three, beta, alpha, and the gamma emissions, right? So this one, look at the atomic number. The atomic number increased by 1 here. The atomic number decreased by 1, mass number increased by 4. So this is 4, 2. If this one, this is going to be 0, negative 1. Actually, this one means this one is beta, and this is alpha. So remember to master the characteristics of those radioactivity topic. And finish like that. Determine the nuclide, determine if the nuclide, this one is stable or not. So to determine whether a nuclide is stable, you find the ratio of the number of the neutrons and the protons. So the mass number is 222. You subtract the atomic number, which is 86, you get 136. So 136 neutrons and the protons are 86. So if the ratio is 1:1, it is stable. If the ratio is not, like this is not, then it is unstable. It is unstable. The nuclide is not stable, meaning it is unstable. State the kinetic theory of matter. Matter is made up of tiny particles which are in a continuous, constant state of motion. That is kinetic theory of matter. Explain how the decrease in volume of a fixed mass of a gas affects its pressure. How does it affect? Remember, when the volume of a fixed mass of a gas decreases, when the volume decreases, the gas particles have less space to move, so they collide more frequently with the walls of the container, resulting to an increased pressure. So when the volume of a gas decreases, pressure is going to increase, right? So actually that's why this is Boyle's law, where we say as the volume decreases, pressure increases. As the volume decreases, pressure increases. Whose law is that? Boyle's law. Study the diagram. So this is an alkyl K, concentrated sulfuric acid, alkene. So this is what we call hydrolysis. because alkene, they are removing water. Actually, it's not hydrolysis, but dehydration. This one is the process called the dehydration, removing of water. So process A is dehydration. So an alkene is formed. So if this alkene L, actually this is, if this is, I can see the 2 carbon, therefore this is ethene. So this is ethene. Ethene will undergo process B to form a polymer, polymer M. Therefore, this is polymerization, addition polymerization. So alkano K is ethanol. Identify, you can write the formula or write the word. The alkene L is ethene, that's correct. Give the process A is dehydration and process B is addition polymerization. Addition polymerization. Addition polymerization. It is addition polymerization. Explain one environmental effect of the usage of compound M. Compound M, that's a polymer. Polymers, they do not decompose because they are non-biodegradable. So if they are non-biodegradable, they pollute the environment. Pollute the environment since it is non-biodegradable. State the difference between temporary water hardness and permanent water hardness. Temporary water hardness can be softened by pouring. Temporary water hardness is due to the process or to the presence of hydrogen carbonate, while permanent is due to the presence of the sulfate ions. Explain why sodium and potassium salts did not cause water hardness? Why? The salts are soluble, hence does not form a white precipitate with the soapy detergents. Explain why filtration of hard water does not remove its hardness. So the ions are dissolved in the water, so filter cannot stop the dissolved ions to pass through. So the dissolved magnesium, calcium ions still passes into the filter because they are actually dissolved. One of the methods used to manufacture sodium hydroxide and chlorine is by the use of mercury cell. The electrolyte used is concentrated solution of sodium chloride. The anode in the cell is made up of carbon or titanium. Give reason. Do not react with chlorine gas produced at the cathode. The carbon or titanium is unreactive with the chloride, that the chlorine gas that is produced. The chloride ions and not hydroxide ions are preferentially discharged at the cathode. It is due to high concentration of the chloride ions. Remember, we talked if the concentration of the electrolyte, if the electrolyte is highly concentrated, then the chloride ions is going to be discharged in compared with in preference of hydroxide ions. Explain why mercury cell is not commonly used to manufacture. Mercury is very expensive and it is poisonous. Mercury is expensive actually and it is poisonous. When a piece of sodium is added to this water in a large plastic beaker, a vigorous reaction occurs and the temperature of the water rose by 25. Write the chemical equation. So sodium plus water, it forms sodium hydroxide plus hydrogen gas. That's correct. Explain why it is not advisable to react a similar piece of sodium with 10 centimeters of water in pouring tube. Now, when you reduce the amount of water, the 10 centimeters cube will, the heat will be very high. The temperature will increase, and that may crack the test tube or the pouring tube and even break it. So the heat produced would break the test tube. Determine the heat change. Heat change, we know it is mass of the solution. The solution was 200. 200, you divide by 1,000 to change to grams, then multiply with the specific heat capacity times temperature change. And that gives us that figure there. The diagram shows the cell used to measure standard electrode potential, magnesium electrode, using hydrogen gas as the reference. This is the salt-rich hydrogen cell, magnesium ion cell. Identify the standard conditions for measuring the electrode potential. The solutions involved must be 1 molar, 1 m. The temperature should be at room temperature, 25 degrees, and the pressure should be 1 atmosphere, 760 mmHg. Identify the ionic compound that could be used. We use as a salt-rich. Salt-rich, we use sodium nitrate or potassium nitrate. The reference potential, the electrode potential is 0 voltage for hydrogen, because that's why it is used as a reference point or a reference electrode. Water is added to a beaker containing the concentrated magnesium chloride to form a solution. Explain the effect of the EMF on the cell. The EMF will increase. Why? Because water will make the ions move even faster, or the movement, the mobility of the ions will increase, therefore the EMF will increase. Thank you. Remember to share this video to as many people as possible. Share, comment. Any problem you face in chemistry, mathematics, do not hesitate to contact. Thank you.